All right, hello. We're back with another question over here. This question is from IB Chemistry HL Paper 1 from the November 2017 batch. So in this question, we've been given this funky looking compound, and the question is, what is the hybridization state and the electron domain geometry around the circled carbon, nitrogen, and oxygen atoms? So this may look a bit daunting at first, but don't worry, it's actually a very simple question. And I will kind of walk through how to do it and some small tips and tricks that you can use to your benefit in the exam. And I'll do that towards the end. All right, so first, let's just look at the carbon atom. So this carbon atom, it has 4 hydrogens attached to it, and then it is attached to 1 nitrogen. Now, what is the electron domain geometry of this? In order to find out the domain geometry, let's first find out the number of domains. So an electron domain is wherever an electron exists around a central atom. In this case, a central atom would be carbon. So over here, we can see that it exists over here, one, over here, and over here. So this is in 4 different places the electron domains exists, right? The 4 different electron domains. And we know that carbon has 4 valence electrons. That means that carbon is actually using all of its 4 valence electrons in bonding. That means there are no lone pair of electrons. So that means all are engaged in bonding. If there are no lone pairs and there are 4 electron domains, which I'm going to call ED, and if you've studied this chapter, you would know that this is called, or the domain geometry is called tetrahedral. So this is called tetrahedral. Now that we found the electron domain geometry, we have to find out the hybridization state. And I'm going to show you a very easy way to find out the hybridization state. The hybridization state can be found by directly looking at the number of electron domains. If there are 4 electron domains, the hybridization is going to be sp3. Well, why is it going to be sp3? Because you have 4 electron domains. That means the carbon needs 4 hybridized orbitals which can engage in bonding. So that's why it's called sp3, because it's s times p times p times p. So it's kind of like p cubed. And you can see there's 1, 2, 3, 4. So there are 4 hybridized orbitals which help the carbon bonding. So that's why it's called sp3. And that's an easy way to find out the hybridization state of an atom. All right, now let's look at these options and see where it says sp3 hybridized and tetrahedral for carbon. And we can see that it's A and C gave us these 2 answers. So we can automatically cancel out D and B. So these are not going to be our answers. Now let's move on to oxygen. Sorry, let me just erase all of this. Now oxygen is bonded or double bonded to a carbon. And we know that oxygen has 6 valence electrons. That means that it has 2 lone pairs because only 2 of oxygen's electrons are engaged in bonding. Now, just a quick reminder, this over here, a double bond, is still considered as only 1 electron domain. It is not considered as 2. It is still considered as 1 because the electrons or the electron density still only exists in this area between the nuclei of the oxygen and the carbon, or these both, they're sharing electrons in this region. So it's still considered as only 1 electron domain. Whereas the lone pairs over here, these are considered as individual domains. So this is considered as 1 electron domain, and this is considered as its own electron domain. So in total, there are 3 electron domains if you count it, right? Now, if there are 3 electron domains, and if you have studied if you've studied this chapter well, you would know that the electron domain geometry for 3 electron domains is trigonal planar. Sorry for my handwriting. And just like in the previous question where we had 4 electron domains and the hybridization state was sp3, in this case, it's going to be sp2. So S times P times P. There you go, 1, 2, 3. 3 hybridized orbitals for 3 different domains. Now let's check out which A or C offers us the sp2 hybridized state and trigonal planar, and that would be A. So we can cancel out C, and A is our correct answer. So hopefully that all made sense to you. If you did not understand how I found out the electron domains by just, the electron domain geometry by just looking at the electron domains, I would strongly suggest you go and revise that chapter once more, because it is very important and it comes in both paper 1 and 2, and it is worth a lot of marks. Now, just one quick tip before you leave. Electron domain geometry and hybridization state are directly linked, and you can use electron domain geometry to find out the hybridization state fairly quickly. So if it's 4 electron domains, it's sp3 hybridized. If it's 3 electron domains, it's sp2 hybridized. And if it's 2 electron domains, it's sp hybridized. So that is a quick shortcut that you need to know. And this will help you a lot in the MCQs, where you have, less time and you need to solve questions fairly quickly. So I hope this helps. I hope you enjoyed the video, and I will be back in the next video with a different question.